Hi, Dr. Cook. I had more of a general question.
Okay.
There's going to be multiple choice on the midterm, is that right?
Yes.
Or, okay, got it. And you take that like during class time and then you do the article analysis?
Yes. So for the midterm, you will come to class in 2 weeks from tonight. We're not going to get on Zoom though. You're just going to go on UB Learns at this time at 4:00, and you're going to open up the exam, and you have 90 minutes to do it. There's 22 questions. I think it will only take you half an hour, and I gave you 90 minutes. So you should have no problem with finishing it. And today, next week, I'm going to help you study. And with what you need to study to be on it. So you should be fine. Next week, I'm going to open up the analysis part where you're going to see your choices for articles that you could choose for the midterm. So you can read through all of those, and you could choose one of your own if you don't like any of those. But I tried to mix it up so there's a variety in there. The one thing that I would suggest is that you read all of the studies before you decide which one you're going to do for the analysis, because I've had in the past where a student picked a study because she liked the content of the study, like the topic was interesting, but she really had no clue how to analyze the data. So don't pick a study if you're looking at the statistics and you don't know how to analyze it. Pick one that you can explain to me. Okay? Does that help, Amrita?
Yes, thank you so much.
You're welcome.
I do have a question about week 9.
Okay.
So if you could just, when somewhere today, if you can just please touch base. I did read the article that we are going to be submitting this weekend. And when we, within the article, when they're discussing the different tables 2 and 3, there's just different abbreviations for an example.
Okay.
You know, if you could just go over those.
Sure, I will.
Because I did my reading and everything, and that was really something that threw me a little bit for.
Yeah, we'll learn it in class today and next week. We'll learn it in class. So today, for the article, I want to just get into the beginning, just the abstract, and get you to wrap your mind around the article. And then you really don't have to read and annotate the article until between now and next week. I'll give you feedback. And then after that, next week, you can write your article analysis. So I'm trying to help you as much as I can. And that is, so giving you kind of a background before you read the article. That's what we're going to do tonight. Then you're going to read the article. I'm going to give you feedback on the things you take notes on. So I'm going to show you, and the things that if you miss some big part of the notes, then I'm going to let you know, hey, look at this, don't forget this. And then in class next week, we're going to go through the most important part of the article. So you should have already read it by then. So you could talk about it with each other and, kind of create meaning together with it. Then write the article. So by the time you go to write the article analysis, you will have had feedback from me, and you will have had, this class and next class where we're going over the key items in the article. So everyone really should do well, since I'm kind of really holding your hand and pointing you out everything that you should be paying attention to in this article. Okay, the one thing that I wanted to point out about the ANOVA article that you read before spring break, and I wanted to just point out what Jenna wrote here. So some of you, several of you did a really good job on this, because we went over it last time, and then I helped you with it in class right before you wrote this article. But I just wanted to show you another good example to see how Jenna included the details that helped show that she understood about these analyses. There were really 2 different analyses in this study. So she says here very clearly, first, they ran a 2x2 or ANOVA to compare the MLGS participants with the waitlist participants. That was the first analysis. Compare this to this. The intervention group, the treatment group with the control group, before and after the intervention period. So she was very clear with this. Then she says there were no significant differences between the two groups prior to the intervention, meaning that they were functionally the same in terms of their depression, anxiety, and stress. This was important detail that we talked about in class that week, that they started out as the same, these two groups. So no significant differences. There was a p-value there, and it told us that there wasn't a significant difference between those two groups. However, she says, the MLGS participants showed a significant reduction in all three dependent variables after going through the MLGS intervention. I can tell that Jenna really understood this, the way she's saying it, ending up with significantly lower scores than the waitlist group for each DV. Okay? What would actually strengthen this even a little bit more is if she gave me the p-values. That would strengthen this more. But this is good because I can see she understands it. Now, she also is mentioning the effect size. If there's an effect size there, I expect that you're going to explain it to me. So she says the effect size varied somewhat, with perceived stress having the smallest, and she gave me the effect size, depression having a moderate effect size, and anxiety having the largest effect size. And she gave me the effect size. So I know she was able to identify those effect size and interpret whether they were small, moderate, or large. And she says here, which is pretty sizable. So she understands that that's a big deal to have a large effect size like that. This is a big deal in their study. So this is where the researchers will celebrate. They had a large effect size. They discovered something important. So she also says, however, the waitlist group did not see the same reduction in symptoms. The waitlist group showed no significant difference in depression or stress when comparing their scores from before and after. Interestingly, their anxiety scores actually significantly increased over time despite receiving no intervention. So she noticed this. So even though the waitlist group, their scores went up slightly for depression and stress, it wasn't statistically significant, so we can't say that they went up. But then she goes on to make kind of a conjecture. So she's using her own thinking here, saying, it's interesting that their anxiety increased. And even as the semester went on, maybe it was because they were on the wait list, is what she's saying. And it could be due to a lot of things, but, she gave her own logic here. And that shows me she's thinking and putting her own thinking into it. So from this description, I don't have any doubt that she really understands the findings of the study. She was able to look at those statistics and be able to tell me about this. Now, this was just one. She also did the same job with the second analysis. The second analysis was when they looked at just the MLGS participants over time. So they looked at the pre, the post, and the 1 month later. So you needed to tell me about that analysis as well, not just this one. Okay, and Jenna did a good job on that one too, but I just wanted to show an example here of how, you can do something like this when you're writing your analysis of the article. Okay, so our learning objectives for today, I want you to understand why we use correlations research. What's the purpose of it? I want you to know the research design types. Okay, just like we had design types for the ANOVA, there's design types for correlations research. I want you to understand the statistical tests that they use to analyze correlation research. And I want you to be able to analyze correlation research studies. So let's start with correlations. What are they? There's two types of correlations. There's some correlations that show the relationships between two or more variables. And there's other correlations that help us make predictions. When this variable goes up, this variable goes down or up or et cetera, whatever. We can make predictions from a correlation. So different kinds of studies have different reasons that can both use correlations. If you're looking for what is the relationship between two or more variables, or how does one predict the other. Now, when we're looking at correlations, and you saw this in the video, but I wanted to go over it because we're going to need this information for the activity that we're about to do. So a positive correlation means that the variables go up together. When one goes up, the other goes up, or when one goes down, the other goes down. That's a positive correlation. But when one variable goes up, the other one goes down, or vice versa, one goes down, the other one goes up, that's a negative correlation. Okay, so correlations have either a positive or a negative sign on them, and that sign indicates whether they go up together or whether they one goes up, the other goes down. Now we also have, when we look at a correlation, we see the negative sign. See here, -1, -0.50, positive. But we also have the number itself tells us whether the correlation is strong or weak. So a weak correlation would be 0. And you can see how all of these dots are data points, and they really are not, they don't have a relationship to each other. They're all over the place. But once they start lining up, then we're starting to see there's a relationship between them. So if we see here, look at the dots, they're starting to line up. This is a low positive correlation, 0.5, okay? So it's a positive correlation. A high positive correlation is 0.9, that would be here, okay? A perfect positive correlation would be 1. So what we're looking at here is that if it's -1 or +1, that means they're perfectly correlated. They're probably the same thing. If it's 0.50, it's kind of between moderate and moderately strong. This one, 0.75, I almost think of it like quarters. 0.75 is going to be between strong and moderately strong. It's a pretty good correlation. Whether it's negative or positive, it's equally strong. So, and this would be 0.25, where it's just a moderate correlation. It's weak. If it's under 0.25, it's going to be weak. If it's between 0.25 and 0.50, it's moderate. If it's between 0.50 and 0.75, it's moderately strong. And anything over 0.75 is a strong correlation. So we're looking at the two things, negative, positive, and how strong is the correlation. So we're going to do an activity now, and you're going to just make a guess, okay? And the guess, it doesn't matter if you're right or wrong. You're just trying to get your hand wrapped around what do these correlations look like? What does the data look like? So remember, a strong correlation is going to be over 0.75 or higher. A weak correlation is 0.24 or lower. And this is called collinearity when the variables are collinear, they match up together. And this is called simple regression when we have two variables. So now, look at this. Good. All right, so make a guess what you think this is. Okay, I'm going to show the responses. Let's see what you think. So some of you think it's 0.44, some think 0.74, some think it's 0.44. Okay, now the next slide is going to show you what it actually is. And this, the correlation is 0.74. So it's a pretty strong correlation. I don't know why it's not showing. Oh, there it is. See, this is the line it shows you. See, it's a pretty strong line, those dots. Each one of those is a different data point, and it's pretty close to that line. So this is a strong correlation. Let's go to another one. Guess this one. Now notice, is the data going up or down? And then what do you think? Is it just as strong as the last one? You don't get any points off if you don't guess it right. That's okay. We're just kind of getting an idea here of what it looks like, what an R value means. So we're thinking maybe negative 0.57, maybe negative 0.87 or positive. Let's look at it. So this is a positive negative 0.57, and that's because this line is going down. Okay, when it's going down, it's a negative. So this is a negative 0.57. Let's try another one. Okay, let's see what we have here. Okay, so it's either 0.09. So you're noticing that it's a small correlation, just not sure whether it's positive or negative. And it's hard to tell on here, but let's see what it is. It's actually a positive 0.09, goes up a little bit, but it would be really hard to tell just by looking at that. So you get the general idea. So when you're looking at a chart such as this, here's a correlation. There's a correlation between autism and eating and organic food sales. So notice here that the data was collected for autism sales and how many individuals were diagnosed from 1997 to 2009. So we look and see, look at autism, and then look at organic food sales. So this is a correlation. It's a strong correlation, 0.997. So do you think that means that autism and organic food sales are linked? Does eating organic food cause autism? All right, so my point here is that correlation does not mean causation. Just because these two things are correlated does not mean that one causes the other. Okay, it's just a coincidence. So you have to be careful. People will look at two variables and say there's a strong correlation, but it doesn't necessarily always mean that one is causing the other, because a correlation does not mean something is causing. It just means that there's a relationship, a similar relationship. Or autism went up during those years, and so did organic food sales. You could look at history to find out what happened during those years that could cause both of those things to go up, but they aren't really related to each other. So look at this one. So here's a correlation between smoking and cancer. So we look at the number of smokers. You'd actually have to do a study and run ANOVAs and all of those kind of tests to get a p-value. You need to have a treatment and a control group and experimental studies. A correlation study is not an experimental study, and you can't show causation with a correlation study. It's just showing that there's a relationship. So this relationship could cause researchers to then do experimental studies to see if this relationship is a cause and effect. But this chart in itself does not show that smoking causes cancer. All it's showing is that during this time period, both of those things went down. Okay? So that's why I'm showing you this to really make the point that correlation sometimes implies causation. Someone might imply it, but it can help us insinuate it. When we look at that chart and we go, oh, look, it's a strong correlation. It must mean one causes the other. But be careful and don't get caught in that trap, okay? So let's look into some correlation research designs. First of all, in the correlation study, sometimes they use the terms independent variables, and at other times they change to these terms. So I want you to not be confused if a research study is talking about these kind of variables. Predictor variable is the same you read that you'll understand what they really are. Since you know what an independent and dependent variable are, you can then assume that you know what these two things are because it's the same. So in a correlation research design, one of them is called a simple regression. This is when a change of one variable influences the change in the other. And I made a little animation for you to help you see this correlation. So when I click this little sign, so if something is a positive correlation, here's an analogy to help you remember positive correlation. Positive correlation is like an elevator because the variables go up together and they go down together. Okay, so that's a positive correlation. It's like an elevator. A negative correlation is like a teeter-totter or seesaw, because when one variable goes up, the other one goes down. So remember that negative correlation is like that seesaw, and the positive is like an elevator. All right, so in a simple regression, if the relationship between the two variables is they go up or down together, it's going to be positive. If one goes up while the other goes down, it's going to be negative. And this helps us make a prediction. This is called a simple regression when you just have one predictor variable and one criteria variable. You might also read in the study that you're about to read, they use the term multicollinarity. And I just want to let you know, because this is when we have more than two variables. They add in multicollinarity, because remember I said collinarity is looking at the relationship between two variables. So multicollinarity is looking at the relationship between more than two variables, okay? And this is called multiple regression, when we have a study and we're looking at how the criterion variable can be predicted by many things. So let's think of the student right here, and we're looking at his grades. What might affect his grades? And we might say his time on his phone or his mobile devices, his relationship with his parents, his activities like soccer, and his teacher. All of those might affect his grades. So we can look at correlations between all of them in a multiple regression. So we'll collect data about how long he spends on his phone each day. We'll collect data about his parents and what they do. And we'll collect data about his sports and about his teacher. And then we can then see how they all impact his grades. This is called a multiple regression. So in a correlation data analysis, we're going to just look at this example here. So in this example, we're going to look to see if there's a relationship between the highest level of education completed and average salary. So when we ask for, we put the data into SPSS and we ask for data, the first thing they give us is descriptive statistics. So here we have